Okay, let's start here. Good morning to everyone. Thanks for being here. My name is Daniel Fernández, and I'm the project lead of Thymeleaf. And today I'm going to make a presentation that is going to be sort of twofold. Okay, there's going to be two more or less separate parts. The first part, about the first two-thirds of the presentation, are going to be about Thymeleaf itself, so it might be useful for you if you didn't know Thymeleaf before coming to Spring I/O, or even to refresh some of the content in the library. And the last third of the presentation, approximately a bit more than that, is going to be about Thymeleaf 3, because we have just published a new version of the library just 10 days ago, last week, and it comes with a lot of new improvements, comes with a lot of new features that are actually very interesting, so I want to present them, almost all of them, to you. So let's start with saying, okay, what is Thymeleaf? Well, first it is a library, of course. It is a template engine for Java. Template engine is that thing you use when you have your data in one hand and then your styles, the graphical part of your application in the other. You want to mix them so that you have style data in your web interface. And it's a server-side template engine. And here I believe I can hear you thinking, oh, server-side templating, that is very 2005. And you'd be right, actually, because it is, in the same sense as client-side templating is 2010. And having both of them, having client-side templating and server-side templating, or maybe even mixing them in the same application or mixing them in order to use the right tool for each job, is very 2016. So there's still a place for server-side templating in 2016. And actually, it is growing right now. So it is a very young project. First version was in 2011. We've only been working on it for 5 years now. We've just, as I told you, we've just released version 3.0.0, which is a huge leap. Nowadays, we have about 75,000 downloads, the core only without the extensions, and it processes HTML, XML, and as of Thymeleaf 3, it processes JavaScript, CSS, and text also. You will normally find it as the view layer of Spring MVC applications. Actually, right now, we estimate, judging from the download figures, that about 95% of our users use Thymeleaf in Spring MVC applications. Of course, it isn't the only view layer that you can use in Spring MVC, but for us, it is a very important scenario. Also, you will be able to use it when MVC 1.0 is a reality. That should be 2017. You should be able to use it in MVC 1.0 applications. That's JSR 371. And you can also use it in Vertex, for example, in Ratpack. In some of the frameworks, you should be able to use it in the future in Spring Reactive when it is a part of Spring 5. You'll know more about that tomorrow, probably. So what does it look like? Well, it looks basically like that when you are processing HTML. What you see there is basically a piece of HTML that looks pretty standard in the sense that it has a table, some rows, a header. You see some text there. For example, for the headers, you see name and price. For the text, oranges and the price for them. But what is important there is that there are some alien attributes. Okay, some attributes that are not standard HTML, and that are the way that Thymeleaf has to inject its logic into the template, to convert the HTML into a working template. These two attributes you see there are basically the most basic ones in Thymeleaf. They are th-text. Th-text evaluates whatever expression comes as a value of it, and just replaces the body of the tag, the body of the host tag, with the result of that expression. And th-each, as it looks like, iterates something. For example, in this case, it might be a collection called all products. It iterates it. It creates a row for the template, for the table, for each of the elements in the collection, and it will, for each of it, output its name and its price with 2 decimal places. So it looks pretty much the same as any other template engine, except for the fact that it actually understands HTML. But you might say, okay, you created this 5 years ago. Why did you bother doing that? Because there were already quite a lot of server-side template engines by them, Velocity, FreeMarker, JSP, of course. So, well, the reason I created this, there are many reasons, actually. Some had to do with elegance, some had to do with features that I felt lacking in some other template engines. But the most important one was frustration. Okay, I've been sort of a mix between a web developer and a data integration developer for 16 years. And for most of those years, whenever I had to create a web application, I had to feel that there was something interfering with my work, interfering with the fact that I wanted my work to be more streamlined. And that thing that I felt interfering with my work was the design development round-trip issue. So what is this design development round-trip issue? This issue is what happens when you have designers, and designers might be actual designers, I mean people devoted to only design, or might be developers working as designers, which very normally happens, They create an HTML prototype, some interface, which enables them, or enables us, to communicate with our customers, to communicate with our users in order to reach an agreement about the design of the application to be developed that allows us to say, okay, do you want it to look like this? No, I want it to look a little bit different, add a page here, make it do something. And when we do reach an agreement with our customers, when we finally have something that looks like what the customer needs, we start to create or to convert this into real working templates, into things that can be put into web server and actually do things dynamically. When we do that, for example, in JSP, they start to look like this. This is not, of course, JSP code, but this is what a JSP page looks like if you make a browser try to open it. Okay, because it doesn't understand JSP tags, JSP directives, they're not really tags. So it might end looking something like that. The problem here is that when you have something like this, you don't have a design artifact anymore. You cannot use this for communicating with your customer. And not having this communicating with your customer might be a problem. Okay, but it is a problem that for lots of time we have been thinking that might not exist, in the sense that we have said, okay, no problem. My design artifacts are no design artifacts anymore. They are not they are not prototypes anymore. But it's not a problem because I'm not prototyping anymore. I'm just developing. So there won't be any problem because my customer will never come during development and tell me I want to make some changes. No customer comes ever during development and asks for changes, except they do. So when they do, what do we do? Well, first, who will be doing those changes? Normally developers. Normally developers because designers, when they are confronted to something like that JSP page you saw there, they will say, no, I don't want to touch that. So it will be developers. That's not really the problem. The problem is that in order to do the changes, we will most normally have to have a working application. Okay, we might have to restart the application. Of course, we can use something like JRebel so that we don't have to restart it, but still, we will need a good part of our application working in order to use the HTML parts of it as design prototypes. For example, if we want to communicate with a customer, if we want to reach another kind of agreement with a customer about the style change in step 5 of a sequence of navigations that has 5 steps, we still need steps 1, 2, 3, and 4, at least working enough in Java in order to reach that step 5 and allow the template in step 5 to execute, to show something useful for the customer in order for us to talk with him or her. So we actually need, we actually are interleaving the development of the application with the design itself. This is not good, and there should be a better way of doing it. This is what's interfering with my work for such long. So the better way I found is natural templates. Natural templates is not a term that I coined. Okay, it's something that just when I created the first version of Thymeleaf, I went to that page in the Wikipedia, comparison of web template engines, and there was an item there comparing all the template engines that was called natural templates. With that definition, templates can be documents as valid as the final result. The engine syntax doesn't break the document structure. And when I read that, I thought, okay, that's exactly what Thymeleaf does. So let's start saying that Thymeleaf does natural templates. It's good for the marketing of the library. How do we do that? So how do we apply natural templates to an HTML prototype? By using non-standard attributes. Okay, it's exactly what you saw on the second slide. The idea is that whenever you add attributes that are not in the HTML specification to your HTML code, browsers will ignore them. Ignore them in the sense that they will do absolutely nothing about them, which is good because they allow you to inject metadata, inject, in this case, instructions for the engine, without it affecting the way that HTML page, which still is an HTML page, it will still be an HTML page, is rendered at the browser. The browser will still render it correctly. In that case, for example, all the browser will see is a list item with apricot in it. The difference between this, using non-standard attributes, and non-standard tags, like for example JSP tags, which again are not tags, they are directives, is that browsers do not ignore other tags, they do not ignore custom tags, because they affect the document object model that is represented in the browser. So they affect the structure of nodes that the browser creates for representing our page, and therefore will affect how the styles are applied to our prototypes, how the scripts are executed on our prototypes, and they will affect, actually, they will put some code, some text that we do not want in a template when we are displayed statically. So this is a much better, much harmless way of doing prototyping and natural templates. Actually, in HTML5, there is a standard way of doing that. We cannot call them non-standard attributes anymore. There is an HTML5 valid way of adding metadata to our templates, to our prototypes in order to convert them to templates, but which is specifying our attributes with names that start with data hyphen. Okay, data hyphen means in HTML5, this is just metadata. Don't do anything special with it. Thymeleaf allows you to use both syntaxes, the one you saw before, the th colon whatever, and this data hyphen th hyphen whatever. You can even mix them if you wanted to do such thing. In this presentation, what I'm going to do is I'm going to use the other one because it is more compact, okay? And I like it more. So now we can prototype, okay? Once we know this, we can have, for example, an image tag like the one you see in the first block of code, which has two attributes. An SRC, that SRC attribute will give us the static functionality, the way for the browser to actually display an image to us, that image there. But that other attribute, the THSRC, will give us the Thymeleaf functionality. That other attribute, when executed by Thymeleaf on a running web server, will evaluate that expression, which is a link expression. In this case, it will, for example, add the application context name as a prefix. It will apply the JSession ID if it is needed. It will, for example, apply URL rewriting. And then, with the result of that, it will replace the value of the SRC attribute, so that in just one block of code, we have something that works both statically and dynamically. Okay? And here you may say, okay, that looks fine, but it's a lot of hassle, because if I'm going to repeat all my attributes for all my tags, for my SRC, my hrefs, etc., it's going to be a lot of code that maybe I don't need. I don't want actually to do natural templates, so I want to do it only scarcely. And that's perfectly fine, because in Thymeleaf, that thing is just a tool. Okay, it's something you can use. It's not something that you're forced to use. So you don't have to repeat those attributes like you saw before. You can, for example, have an image with just a THSRC attribute like the one you're seeing there, and then you don't even have to use things like TH-text for outputting text. You can even use inlining. Like, that's what you see there, that session username expression between double brackets. That means, hey, Thymeleaf, get this, evaluate this, get the result of this, and just output it here, just as if it were a JSP page, only with double brackets. Okay? So at first, I'm telling you that natural templates is fantastic, and now I'm telling you that you can avoid natural templates. So what is the good way of doing it? Normally, well, it says virtuous in the middle. So what I'm seeing more and more is people selecting some templates in their applications, those that are more representative design-wise, those that allow you to communicate design with the customer, and applying natural templates to them so that they are valid design artifacts. And then the rest of the templates in the application, doing them with the less amount of code possible, the more compact code possible, so that they have the best of both worlds. Okay, they have prototyping when they need it, and they have quick code when they need it too. Okay, so far, we've seen what natural templates is. We've seen one of the main reasons why Thymeleaf was created in the first place. But there's much more to it. That was at the beginning. From them, we have been growing. We have been adding lots of features. Of course, all the basics are covered, like conditionals, etc. But there are some more things that are worth explaining in Thymeleaf. Let's have a look at them. For example, page composition. Layout is probably one of the most looked after features in the templates engine. It allows you to reduce the amount of duplicate code, and there are many ways of doing this in Thymeleaf, really a lot of them. One of the most popular, for example, is a dialect that is actually something from an ecosystem, an external dialect called the layout dialect. But what Thymeleaf allows you to do is by means of two attributes, I mean the standard way of doing this in Thymeleaf, is by means of two attributes called thinsert or thinclude and threplace. Get fragments of all the templates, of all the HTML pages, and just insert them into your templates. And it allows you to do it in a very flexible way. For example, if you have a look at the syntax there, that footer : copy, that means, hey, get the footer template, which will be probably prefixed with something like /webinf/template/ then footer, and then suffix it with .html, for example, and get the copy fragment. And copy is a markup selector. Markup selectors are very flexible, but this is the most simple incarnation of them. Most simple incarnation of them in the sense that it simply means if you can reach there, if you can find there a th fragment attribute anywhere that has the value copy, just use that. And that's exactly what it will be doing. It will find a fragment called copy, it will just insert it. Most simple case. But markup selectors are much more flexible because they allow you to insert fragments of code from pages, from templates that don't even know that Thymeleaf exists. For example, in this case, we might have something like a banner server, something like that, and that banner server might be serving HTML without any th fragment attributes at all. All it has is just piece of HTML, and we want to extract a div tag, which has class banner, where we can do that with markup selectors because they have a syntax very similar to CSS selectors or to jQuery selectors. Okay, actually, in this case, we are retrieving the template from a URL. We are making Thymeleaf do an HTTP call to retrieve the template from the banner server, and we're getting any part of it with this kind of selectors. It is a very flexible syntax. You can add attribute conditionals. You can add lots of things. More on fragments. Fragment with parameters. We can do something like whenever we specify a fragment, specify a couple of attributes to them. Well, not a couple, one attribute, 11 attributes, the number of that we want, and then use them inside the attribute. Sorry, inside the fragment. That will allow us to call the fragment as if it were a function. Okay, we can call it, as you can see in the piece of code in the bottom of the slide, we are calling that fragment called joiner, which is in the same template. That's why there's nothing in the left side of the double column. We can call that joiner fragment, specifying values for those two attributes. Why is this interesting? Because, for example, it might allow us to create libraries in jar files containing lots of pieces of HTML that might be called from all our applications. So we can create libraries of HTML fragments. They might even include their own internationalization, okay? Because Thymeleaf can resolve its templates from almost anywhere. So this is very flexible. We are able to add fragments from lots of places. Sorry. Extending Thymeleaf. There are many ways of extending Thymeleaf. Thymeleaf has many extension points. You can add extensions for example, resolving templates from somewhere else that isn't out of the box supported. You can add your own utility objects to the template. But the most important way of extending Thymeleaf is by creating dialects. And dialects allow you to add processors. Processors are attributes, tags, new functionality that you want to add to your templates in the form of, well, attributes or tags that you will be available to all your templates in order for them to be processed. Actually, what... oh, I'm sorry. Everything you saw until now is a part of the standard dialect, which is the dialect that is applied by default. Not even the standard dialect is required. You can actually disable it. So you can create your own custom dialect with your own functionality. You might have, for example, a block farm of some kind, and allow your users to customize their templates by using only the functionality that you want them to use, something that is really safe for you. And they can use it just like that without even knowing that they're using Thymeleaf. Okay, so it is a sort also of a template engine framework. Testing. Thymeleaf has its own testing library, which is very originally called Thymeleaf testing. And the Thymeleaf testing library allows you to create tests for your view layer. Tests that look like mere text files, they look like that. In that file, you see how we are selecting the template mode, which is HTML. We are specifying a context. This is variables that we want to be available in our template. We could specify messages, internationalization messages. We are specifying an input. In this case, we are explicitly specifying an input because we have a piece of HTML there, but we could just have there a path to one of our templates, okay, a path to the templates in our own application, because in this case, we would be testing Thymeleaf itself. You don't want to do that. You want to test your application. We could specify the output. We could say, okay, it has to look like this. Again, it could be a path to a file containing the output. And we might create lots and lots of these files and just throw them in a folder and have Thymeleaf testing execute them in an automated manner. Okay, from where? From, for example, JUnit tests. That's something actually we do. We have some 4,000 and something tests of this kind in Thymeleaf, and we launch them from JUnit tests, and they allow us to test the functionality in Thymeleaf, but they might allow you to test the functionality in your applications, how the view layer is created in your applications. Okay, so Thymeleaf 3. Thymeleaf 3 has been in development, I think, almost forever, but it's been only from July 2013. Actually, the development of the 3.0 branch started there in July 2014, but there is a specific part of Thymeleaf 3, which is the new parser, which is a completely separate library called AutoParser, which I started developing in late 2012, already having in mind that it would be the parser for Thymeleaf 3. So it's from 2012 I've been thinking about what Thymeleaf 3 should look like. Okay, it is a complete rewrite of the engine, in the sense that about 85% of the lines of code, of the about 60,000 lines of code in the core, are new for this version. It's almost completely right. And about 40% of the lines of tests are also new. Of course, we are reusing lots of tests from previous versions because everything should still be working. But we have so many new features, so many new functionalities that we need a lot of tests. And that last line there is because, well, you know, cars, machines, industries, they are measured by the carbon footprint, okay, the amount of carbon dioxide they release to the atmosphere. And we developers are, in some sense, sort of machines that turn coffee into lines of code. So I believe software development could be measured also in coffee footprint, because there has to be a part of the earth devoted to creating coffee for us to create software. So in this case, the coffee footprint of Thymeleaf 3, I actually round out the figures, so that is more or less quite approximate, is 220 liters of coffee, which is quite impressive, I think. Well, first, the most important thing in Thymeleaf 3, we have a new architecture, okay? New architecture means that until Thymeleaf 2.1, what the engine looked like, what the internals of the engine looked like, was a DOM-based engine. This is, we basically got the templates, we created a DOM tree, document object model of nodes of the template, we applied our processors, our logic, on that tree, so that what we had as a result was another DOM tree that looked like the one at the beginning, but had all the transformations that we had. And then from that resulting DOM tree, we started generating output by traversing it. Okay, problem is, for example, if you had an iteration of, for example, a collection of 1,000 elements, you'd end up having a DOM tree which has a subtree, a part of that tree, repeated 1,000 times before starting generating output. That is suboptimal at best. Okay, so one of the reasons we wanted to change it is in order to get better performance and better memory footprint. What we did is turn it into an event-based engine. So now you'd have basically the parser, or maybe the cache, most normally the cache actually, generating events. Those events are an open tag, a text, a close tag, a standalone tag, a doc type clause, whatever, and passing those events to a chain of handlers that are going to process them. Once the chain of handlers process them by, for example, applying all the processors, all the attributes that should be applied, they will start already generating the output. So, for example, whenever we process the doc type clause, we will go all the way to outputting the result of the doc type clause before starting processing the open HTML tag. So this reduces latency, this reduces memory footprint, and this, of course, reduces the full rendering time. That is one of our benchmarks for Thymeleaf 3. You see the difference between 2.1.4 and 3.0. That's based on one of our example applications. It's running Spring. In this case, that benchmark is using Spring, and the Spring expression language compiler, which we are able to use now. And you see there's a very big difference, and that's only a difference in each of the 5 pages, which are very different scenarios, one for the other. It is a very big difference in rendering time. Okay, that only measures the rendering time, but there's also a very big difference in memory footprint, of course, and a large difference in latency, because we will start producing output very soon. And all of the most important pieces of Thymeleaf 3 is HTML5 support. Of course, we were supporting HTML5 before, but the problem was that we were using XML parsers, okay, until Thymeleaf 2.1. The reason for that is that when you're using a parser, parsers are normally meant to give you information about what they are parsing, but not to allow you to reconstruct fully what was originally at the input. So if we were using an HTML parser, all HTML parsers by the time we created Thymeleaf were losing lots of information that we needed for creating output, because we had to create something very similar to what is at input. So they weren't good for us. XML parsers were better in that for us. The problem is, of course, an XML parser forces you to create XMLized code, which means that, yes, you might support HTML5, but people will have to close their tags, we'll have to put quotes around their attributes, we'll have to, for example, standalone tags, we'll have to minimize them, etc. Lots of people didn't like this. Well, and what we did is, by creating autoparser, which is the new parsing library, and you can use it for many other things, but it was created with Thymeleaf 3 in mind. You no longer need to use XMLized code. Now you can just do HTML code, normal HTML code, without having a tag balancer before. So right now, things like, for example, that template you see there, that piece of code you see on the bottom of the slide, is a valid Thymeleaf template. There you see an ng app, which is an attribute without a value. That's perfectly fine now. You see a th text that has an attribute without quotes, perfectly fine now. And you see there are no closing tags, and that's perfectly fine now. Even more, autoparser will know where each tag ends. So for example, if you have two div tags, one after the other, it will know that the first one has to be closed before the other one can open, because that's what the HTML specification says. Okay? More than this, improved inlining. This thing inlining is something that already existed. Actually, I showed it to you some slides ago. Okay, but until Thymeleaf 2.1, what you had to do in order to have inlining is to specifically enable it by adding an attribute somewhere in the containing tags called th_inline with value text. That made Thymeleaf scan all the text nodes, all the bodies of the tags, and look for those kind of structures, that double bracket structures, and output the results of those expressions. Now in Thymeleaf 3, that is a first-class citizen, so you don't really have, actually you shouldn't enable it explicitly, because it will actually be better, be faster. You can do inlining anywhere in the bodies of the tags, and you don't have to do th_inline anything. So this is just another way of outputting things. Of course, natural templates will not be available to you if you do that, but that's your choice. Also, in Thymeleaf 3, we have the possibility of not only processing markup, this is HTML and XML, we can now have text processing. Okay, text processing means that we can just get a piece of text that doesn't have any tags, any HTML or XML tags, and apply logic to it. Apply logic by doing some kind of placeholders. You see there's something with bracket and a hash symbol. Those are placeholders. Those are the substitutes for tags. Okay, there you can apply all the logic that you want. Almost all the attributes available in the standard dialect for the HTML or XML modes are available for the text modes, which are these three. And you can do things like, for example, in this case, a text email. It's not a rich HTML email, it's just a text email. You can do text processing like what most other template engines do, because they are normally text processors, okay? So in this sense, the amount of things that Thymeleaf can do as a template engine has broadened a lot. Actually, there is even a way of outputting, of doing inlining unescaped, because there you see expressions that instead of having double brackets, they have bracket parentheses. That means output is unescaped, so it is, which is a much better fit for text processing. This thing you can do it also for JavaScript, you can do it also for CSS, and for example in JavaScript, it has a very nice consequence, which is the fact that you can do JavaScript natural templates. And JavaScript natural templates is the same thing as we are doing in HTML, but now we can have a JavaScript file. It can be a .js file right now in Thymeleaf 3, which looks like the top of the code in the top of the slide. That's session username. That is an inlining expression, okay? But it's a special inlining expression because it has some comment symbols wrapping it. When your browser executes that, when you just open it in a browser, the browser will perfectly execute that because it will just output hello John Apricot. That comment it will be ignored. Your code will work perfectly fine. But when Thymeleaf executes that, it knows that it is a special inlining operation that will require not only evaluating the expression and outputting it, but also removing whatever comes out of that comment until the semicolon. So the result will look like the one you see in the bottom of the slide. So you will have now a piece of JavaScript that will actually look statically and dynamically, which is another iteration in the natural templates thing. And more about fragments. Well, you remember those fragment insertion things that I showed you at the beginning. Now the fragment insertion expressions, which are like the ones that you see in the first line, that common header, have been generalized. This means that now we have another way of specifying them by just adding tilde brace, okay? Well, another close brace at the end. That means that now we can use those expressions, those tilde expressions, wherever in a template. In most cases, in most places of our templates, fragment expressions will be useless, but there is a place in which they are really useful, which is as parameters of another fragment expressions. So for example, you can now do something like what you see in the bottom piece of code. You are calling here a common header fragment, which will replace the header in your template, and you're passing to it customizations to that common header. Customizations in the form of HTML, because what you're passing are basically the title node, or sorry, the title element, and all the link elements. Those are markup expressions, normal markup expressions like the ones we saw before. So now you can have common pieces of fragment that you can use in all your applications, and you can customize them by passing them another fragments of HTML. For example, in a header, you might pass the specific JavaScript files that you need for that template, or you might pass the specific styles, etc. That is something that until now you could only do with the layout dialect. You can do it now out of the box. Okay. Another interesting thing, decoupled templates. Decoupled templates is a feature that I've been promising since Thymeleaf 2.0, and the idea is that you should be able to have your templates specified as pure HTML. Okay, pure HTML means no Thymeleaf code at all, no Thymeleaf attributes, nothing that is not just HTML. What you should do with this is then create another file, which location can be customized, but normally Thymeleaf will expect to find it in the same folder, called, in this case, fruits.th.xml. And that special logic file will actually have lots of selectors, tags like those utter with a cell attribute. Those selectors will be markup selectors, and they will specify the place in the original template in which you want to add your logic. So you will be injecting your logic externally. So for example, in the first utter tag, what it's doing there is selecting whatever has ID detail. Inside of it, there should be a tr, that's the table row. So there, please add the thf fruits. That is the same as if we had placed the thf fruits inside the tr in the original template. The same for the th text, the same for whatever you want to add. You can actually do them hierarchically. So now you can just get your templates from the designers or from your personality as a designer, get them, not touch them at all, and add them whatever logic you need to add them externally, so that natural templates is even more evolved this way. You don't even have to touch anything in your templates anymore if you want to do it that way. Again, the location of these files is customizable. It's another extension point. Okay, and last point, very important point, reactive friendliness. You know, in the latest times, there has been a lot of movement in the reactive world, of course. There are many reactive frameworks in the Java world that have become quite popular, like Vertex, like Ratpack, etc. But it seems like server-side rendering in those frameworks is not completely optimized. The reason for this might be twofold. Probably the most important one is that it is actually difficult to make a template engine, a server-side template engine, work correctly in a reactive framework. Okay, it is difficult because in a servlet API-based application, you have a response. That response has a writer. You can just pass that writer to the template engine, and the template engine will just write there. But in a reactive framework, you normally don't have that. You have something which is a subscriber expecting buffers from you, expecting byte arrays from you, which are the output they will be outputting, and you have to make somehow the engine stop when it produces a byte array of the specified size, send it to the output channels, and then wait for a request from the output channels to generate more, to start again from where you stopped. That is something that is very complex from the architecture of a template engine. So that may be probably the most important reason why it isn't optimized in most reactive frameworks, also because maybe they are just focusing on client-side rendering, okay? But the problem this way of using template engines in reactive frameworks has, is that it is highly unoptimized, in the sense that you normally have a context that has to be completely resolved before executing the template engine. So if you have publishers of data, reactive publishers of data, you'll have to resolve them into iterables or collections or whatever, then send them to the template engine, have the template engine generate a very large string with the entire result of the template, and then call in the output channels once with that big string, and tell them just send this to whoever is listening at the other side. So latency is going to be not good. Scalability at the end is not to be really good. Also, we are seeing more and more that hybrid rendering is starting to be a thing. More and more people are going towards an architecture in which they are pushing the HTML rendering back to the server. For example, in Twitter right now, you have the first shot of tweets rendered on the server side, and then incrementally things come in JSON, but the first part is server-side rendering. So in this situation, we thought that Thymeleaf could help reactive frameworks by creating some kind of hooks in which they could add their extension, they could add their own integrations, and make life easier, make server-side rendering better in reactive environments. Okay. First point, of course, was achieving full independence from the servlet API. That is something that already existed in Thymeleaf 2.1, but for non-web applications. You could do web applications with the servlet API or non-web applications without the servlet API. Those frameworks like, for example, Vertex that didn't use the servlet API but wanted to use Thymeleaf did have to mock the request, mock the response. It wasn't really beautiful. So now for Thymeleaf 3, we have achieved complete independence from that. You can use it in a web application with full URL support, for example, full context support, even if it doesn't use the servlet API. And then we defined 3 reactive-friendly operation modes. The first one is basically what already existed, so we created 2 more. They look like this. The one on the left is the normal way server-side template engines are used in reactive frameworks, okay, which basically you have a context. That context, if originally was meant to have some kind of publisher, some kind of reactive flow of data, will have to be resolved into an iterable of data of some kind, so you won't be binding to that publisher of data. Then once you have the context completely resolved, you will call Thymeleaf. Thymeleaf will generate a large string, very large string, and that large string will contain the entire output, and you will call the output buffers the output channels once with that result. Okay, this is how Thymeleaf is being used right now in most reactive frameworks. But what we can do now, what we can create in reactive frameworks from Thymeleaf 3, and actually it is something that we have already tested for Spring Reactive, which is going to be a part of Spring 5, is 2 new operation modes, which are, first of all, the buffer. The buffered one means, okay, don't mess with the context, we leave the context as it is, but we are going to do the template engine by means of a mechanism called engine throttling. We are going to make it be able to create buffers and send them to the output channels of a specific size, and the template engine will just create the buffer of that specific size, stop there, send it to the output channel, and wait for the output channel to ask for more. So it will work as a publisher of output, as a publisher of byte arrays, of output buffers. All of this single-threaded. Okay, we don't have to have the template engine working in a separate thread or anything. It will just be single-threaded, waiting for more requests of buffers to come. But we can go even further. Okay, we can make Thymeleaf actually in the 3rd operation mode, in the data-driven operation mode, with a bit more of integration. We can make it work in a sort of fully reactive way, not fully reactive because Thymeleaf isn't itself reactive in its architecture, but it will integrate very well with reactive frameworks, so that Thymeleaf binds itself to one publisher of data. You select out of your context, you select one variable, which is a publisher of data, just as if it were a JSON feed, a JSON stream of data going out through an API call, through the payload in the response of an API call. But instead of that, you're going to be generating HTML. So you select one variable in your context that will be a publisher of data. That publisher is reactive streams terminology, okay? You could call it an observable, for example, if you are used to work Java. And then Thymeleaf will basically be executed as a consequence of that publisher of data calling our next methods. This is what will be driving the execution of Thymeleaf. You expect them to have a template with a th each, okay, with an iteration, and that iteration will point to that variable, to that publisher. And Thymeleaf will get the order of executing from the reactive flow from the publisher. It will execute to the point that the flow that the publisher of data has provided data. It will stop there, send the output, and then wait for more requests to come. So requests will come from the output channels to generate more buffers, and then we will send them back to the publisher of data to send more data. Then we will send more data, we will execute it, we will send the output. So it will be just one step in the flow of data, in the reactive flow of data. In this case, in reactive stream terminology, we are working as a processor, okay, as a processor of input data, output buffers. The result is, of course, that we are reducing memory usage, that we are making things work better from a reactive point of view, and that as all the reactive things are meant to, we are providing more predictable scalability thanks to this. And that's it. Actually, I've been quite soon. It's only 40 minutes. So if you have any questions.
I have several questions.
Hmm?
The first one is like in fragments. Usually the fragment requires some data, right?
Mm-hmm.
Somehow possible to actually go through, not just include a fragment or insert a fragment, but go through a controller and then the controller into the fragment?
You
So
could,
like,
yeah, you could do that actually. For example, it depends on the template resolver that you are using, okay? You can configure several template resolvers. One of them could be the HTTP one, the one that you saw calling the banner server. That one could actually be calling the application itself and asking it to retrieve whatever comes out of the execution of that URL. It might be in your own application, why not?
great. The next question is there, because you said that it's server-side rendering, is there a plan to be a client-side rendering as well? Like, I know it's very hard, but currently, like, you should have some client-side rendering, some client-side integration in any project. And what is currently happening is like you have server-side rendering, and then you have the handlebars, mustache, or some logic with the place that everything is messed up and messed up, and you know that parts of the file are server-side rendered, the other parts are client-side rendered, and you have to mess up two different syntaxes, two different expression languages. It's kind of tricky. So is there any plans, not maybe by you, but some third-party developer to provide a client-side rendering infrastructure?
And the client side. Well, okay, we have no current plans as of isomorphic templating right now, okay? We do understand that. Right now, our strategy focuses on integrating in the best possible way with any JavaScript side technology, I mean client-side technology. Actually, by having natural templates, what you can do is actually being able to develop your client-side more easily in your already working templates, okay? We do have, for the probably far future, an intention of creating some kind of JavaScript library, okay? But it will most probably have only a subset of the features of the current server-side side of Thymeleaf, because actually there are many things that cannot be done at the client side.
And the last question is, why did you decide to have so many? Okay, but I'm loud enough, I guess. But what was the reason? Why did you decide to have so many different expression types? Like in a JSP, in the mighty JSP, you have currently the JSP expression language, which is the simplest possible expression language, and you have one syntax for expressions. Yeah. Of course, I've always missed the way to say I want this to be escaped and without needing to put C out and stuff, but it looks like you have so many different constructions, like with the tilde, with the add, with the too many, and first it's kind of hard for someone who is not using Thymeleaf to start using it. Second, it's and it messes up with some JavaScript framework because maybe some JavaScript template engine is using some of the symbols, and it's kind of like weird. So why did you decide for
that? Well, actually, there are exactly 4 types of expressions, okay? These are the variable expressions, which are the ones that get your beans, the objects that you have put in your context, and just execute whatever on them. That is the only thing that JSP can do. That's why JSP only has one way of expressing it. Then there are internationalization expressions, which are the one with the hash symbol. That is something that in JSP, for example, you have to do with a specific tag library. So we do that from an expression because it allows you for great flexibility. You can use them anywhere. Then there are the URL expressions, which are the one with the @ symbol. That is something, again, that you have to do in JSP with a specific tag library. Also, you can have even, for example, if you're using the Spring tag library, you might have a way of doing it in JSTL and another different way of doing it in the Spring tag library, which aren't the same because the Spring is applying things that do not apply here. We integrate that in only one, so you only have one kind of expression and you can use it anywhere. And then there are fragment expressions, which are the new ones. The reason for fragment expressions is actually being able of getting pieces of markup and throw them around using whenever you want in your template engines. That's something JSP definitely cannot do. So the reason we have more kinds of expressions is because we can do more things, actually. Okay? Any more questions? I think the microphone might go.
It's a simple question, actually. Does Thymeleaf 3 support type safe?
Type safe? What do you mean with type safe? No, our expression language is dynamically in the sense that it won't bind you to any specific. It won't know what types your data are. It will just execute on them. So, for example, if you have my being dot my property, it expects you to have a getter for that my property, something like get my property, but it won't check that at compile time.
Okay, it supports JavaScript, but does it support TypeScript?
No, not that I know of. I'm not familiarized with TypeScript, to be honest.
Okay, it's the new way for defining type-safe things in JavaScript.
Right. Well, if you can do that in an HTML page, you can do it in Thymeleaf, because basically a template in Thymeleaf is just an HTML document. So whatever you want, you can do in an HTML document vanilla without adding any kind of template engine metadata or template engine logic. You can do it in a Thymeleaf template perfectly fine. Okay. So in that sense, yes, we should. Okay.
Okay. Another question: how many developers do you have? Is it just you who's
Three.
working?
Three. One here, another one in Ireland, another one in New Zealand.
Okay. Do you have any other support from other companies?
We have lots of contributors, yeah. We are currently, well, we are receiving pull requests from time to time, and some people do more things, some people do less, but yes, we have a large team. Actually, there's a page on the website in which all the contributors are listed. I don't know, we might have something like 20, 25, 30. Okay.
I'd be interested if you have some higher level libraries which do the more complicated stuff, which sometimes tag libs provide already, such as autocomplete, where you just have a special tag and it brings in all the JavaScript and some binding all together already.
You mean autocomplete from IDEs, for example?
Yeah.
Well, that's something, yeah, it is part of the tooling in this case. We have an Eclipse plugin, which is prepared to use Thymeleaf. So that Eclipse plugin will allow you to easily create your Thymeleaf templates. And with regard to IntelliJ IDEA, actually the IntelliJ IDEA guys create a Thymeleaf plugin, which allows you to have autocomplete of variables, know all the attributes in Thymeleaf, etc. So if you have the latest version of IntelliJ IDEA, it comes already with Thymeleaf 3 support. So you should have that supporting tooling already.
I meant more like if you want to client side, you want to have a field which is auto-completed, looking up a REST service, providing some fields. I mean, you need to add quite a lot of JavaScript and the things yourself into the Thymeleaf template, since it's client side.
Yeah, but client side, we are not executing client side, so yeah, everything you want to be executed.
I mean, some libraries which add all this already by just adding a Thymeleaf tag or something which brings in all this functionality.
Not in the core of Thymeleaf. You can create dialects.
You can create that yourself.
Yeah, there might be something in the ecosystem that allows you to actually add your libraries with only one tag or something like that. Yeah. Not in the core of Thymeleaf. In the core of Thymeleaf, we don't have
you stick to the core of just the framework processing.
Exactly. But we have actually a very large ecosystem with a lot of dialects. We know of many of them which we list in the ecosystem page in the website, but there are actually lots of them. I know there are lots of dialects which I don't know about. Just find them somehow.
Okay, thank you.
Okay. Any more questions? Thanks a lot, then.